So if I were to have given you H2SO4, who is that, by the way? Good, sulfuric acid. Okay, strong or weak? Strong, good, okay. If I were to give you this information and ask you for its conjugate, okay, you would be giving me its conjugate base, okay? You're giving me its conjugate base. Well, what do we know according to Bronsted-Lowry definition? What do acids do? They donate, good. So we know that acids are going to donate, bases are going to accept, right? Now, this little list, it kind of is confusing because what I'm asking you for is its pair. So I'm asking you across the arrow what now exists. So you can kind of see in the little equation next to this that you have this combination. This was the acid, this was its conjugate base. Okay, so we're not talking about on the left-hand side of the arrow, these are my reactants, acid, base, they mix together and then boom. We're talking about across the arrow. We're saying the before picture and the after picture, okay? So another way that this top equation could have been written, and just go ahead and write it this way, is H2SO4, put it in some water. Let me give that little back and forth arrow there. Okay, we said that it donated, so give yourself an arrow showing that. And now we're left with its conjugate base, right? So the HSO4, what do you notice this HSO4 also has on it? By the way? Yeah, it has a charge now because it gave away something positive, so it became more, what? Negative, good, all right? So this is its conjugate base, and then what happened to the H2O? What did it turn into? Hydronium, yep, H3O. Okay? So that is really what's being shown here. And so then what you can see is that this is the acid, this is its conjugate. What is water acting as? Oops, meant to do that in a different color. Water is acting as a what? If this is an acid, what does this one have to be? That has to be a base, okay? And then H3O would be the conjugate acid, okay? Conjugate base, conjugate acid. So at least label one so that you have one example that you can come back to and study, okay? We're going to do it with two other ones, and then we're going to skip the equation for the rest of the page, all right? Because I need you guys to be able to, I give you something and tell you that it's a Bronsted-Lowry acid, what is its conjugate base? Something is a Bronsted-Lowry base, what is its conjugate acid? And you need to be able to do that. So let's look down at a base example. Okay? Let's look at number 3. All right, so the base that I'm giving you is F minus. Okay, it's a fluorine ion. So we're going to kind of do it the same way over here. We're going to say F minus. We're going to add it to some water. And that just helps you see that an H isn't just appearing out of nowhere, okay? All right. What would the product be? If it's acting as a base, what does that mean the hydrogen is doing? Is it coming towards the F or going away from the F that doesn't have an H to give away? It's going towards it, right? So we have this little, water is going to be donating an H. So what would that product now be? Right? So hydrofluoric acid plus, who's left over now for water? Yep, OH, hydroxide, with a little minus. Okay, so now let's match them up. Fluorine acted as the what? What did the problem tell you it acted as? The base. So we're going to put a B right here. Who is its opposite? Who is it connected to? Good. So this is its what? Conjugate, nope. Conjugate acid. Good. What did water act as? Acid. And it's connected to the hydroxide, which would be its conjugate base. Perfect. Okay. Just try not to. Just do your best. I don't know yet. Sorry. All right. Okay, so what I'd like you guys to do, okay, is I would like you to try the equation thing with 2 and 4. Okay. So just to set you up, that means you're going H3PO4 plus water. And I want you to tell me the products. Okay.
Are we always going to use water? Good.
So 4 should be, we're going to have NO3. He's acting as a base this time, so show the direction of that H. Hint, nitrate doesn't have an H. So you should be able to handle that one. Okay. But I want you to write your products. Okay. And then just know which ones are going together. After you've done those 2 things, I'm going to give you a little bit of time. I'd like you to write in all these missing boxes. Okay? So think about the definitions. If it's an acid, take away an H. If it's a base, give it an H. Okay? And that's what goes in the opposite box. All right. So you guys take a couple of minutes to do that, and we'll talk about the answers. Okay. So for number 2 and 4 that you were supposed to do for the equation side, okay, hopefully you saw that it was acting as an acid, so it donates the H to the water. Okay, so water was acting as a what here? As the base. Good, okay. And then H2PO4, don't forget that minus. It lost a positive thing, so it becomes one more negative. Got it? Okay, so H2PO4 with that minus, this is its what? What is that called? Conjugate base. Good. Okay, conjugate base. And the H3O is called a conjugate acid. Okay, do you see that? Acids and bases are on one side, conjugates are on the other. Do you see that? So conjugate is just kind of the after picture. All right, so once you figured out an acid or base, conjugate is what happens after, and it's always opposite. All right, so for this one down here, so this is what you should have had right here. Okay, we did this one together. So down on the next one, we had NO3, and it was acting as a base. So that means that water is going to donate the H, right? So what was water acting as in this one? That is an acid. Okay, so remember, water is amphoteric, goes both ways. Okay, so it donates the H to make, what is this called? This is nitric acid, but what is this called in terms of this? This was a base, so this is its conjugate acid, and this is its conjugate base. Okay? Kind of getting that? All right. So the rest of these little arrow things that I have down here, all that that's showing you is that this gave it away. This one gave it away. This one took one. This one gave it away. Took, okay, that's all that that's showing on that side. So I'm going to kind of ignore that and just shift this over a little bit. All right, so the rest of your answers, double check them with me. Make sure you got your negatives and stuff right. All right, so this one, HNO3, it added an H, no charge. This one, we took away an H. So HPO4, it already started as a minus, so it needs to end with a -2. Water, acting as an acid, will give away an H. So we gave away an H, it gets a minus symbol, hydroxide. HSO4 with a minus gives away an H. So now it will be SO4 with a 2-. This is the sulfate ion. I am so sorry. I did that one backwards from what you guys were supposed to do. So you started with a sulfate ion. It takes on an H, so it moves to only a -1. Okay, here we have HPO4 with a 2-, give away the H. Now we have, Miss Vogel forgot her number, -3 on that one. It was a -2, took away one more positive thing, so now it's a -3. Okay, this one, NH4 had already a positive charge. It gave away an H, so we have NH3. No more charge, it's neutral. Well, who is this called, by the way? Ammonia, good. Okay. And then down here we have water acting as a base, so it will take on an H, therefore get a positive 1 charge. Are there any questions on those? Okay, so big important thing down here at the bottom, okay, is asking yourself which is a stronger base. So hopefully you're looking at this and you're like, okay, well, Miss Vogel, you told me that things that have H's in the front are acids. Yeah, okay, so cool. But this is using the Bronsted-Lowry definition. These are both polyprotic acids in their normal form. So that means sometimes both of these are not in their normal form, right? They're ions, they're conjugates. And so we're looking at when they're acting as a base. So if they're acting as a base, just go ahead and rewrite them below. Oops, I gave that one away. All right, acting as a base, what does that mean it's gonna do with a hydrogen? It's gonna gain a hydrogen, right? It's an acceptor as a base. So we're gonna take this little H that's gonna join in, and what do we get for the first one? H2SO4. Cool. Who is that acid? Yeah. Sulfuric acid. Is this a strong or weak acid? This is definitely a strong acid, okay? Because if I count this, 4 minus 2 gives me 2. 2 or more oxygens, strong. Okay. The other example that we've got was H2PO4 with a little minus. Acting as a base, it takes on a hydrogen to make H3PO4. Who is that? Phosphoric acid. Okay, phosphoric acid, strong or weak? It's a weak acid. Good. Because if we take 4 minus 3, it only equals 1. That's not enough. Okay, so now we've at least figured out who they become, right? So these would be if this is the base, what are both of these representing? Conjugate acids, right? Okay. Or you could say these are acids and those are the conjugate bases. They're just conjugate pairs. Now let's read the important statement up top together. Okay, it says after an acid has given up its proton, it's capable of getting back that proton acting as a base, right? So conjugate acid bases. Conjugate base is what's left after the acid gives up a proton. So remember, I've kind of told you that. It's after. Conjugates are always the after picture. Okay, this is the statement to make sure you have underlined and highlighted or whatever. The stronger the acid, the weaker the conjugate base. And vice versa. The weaker the acid, the stronger the conjugate base. Okay, so it's going to work both ways. Okay, so knowing that statement, that the stronger you are as an acid, the weaker your base is. The stronger you are the weaker you are as an acid, the stronger your base is. So knowing that statement, let's answer the question. Which one of these is considered a stronger base? Yes, okay, it's the H2PO4. That's your answer. Because it had the weaker acid. The weak acid made a stronger base. Okay? You will see a question like that, I promise. I'm going to ask you to tell me what a conjugate is. If I give you something, and then I'm just going to say, hey, does it have a stronger or weaker? All right? So that statement that you just highlighted at the top, make sure you studied that statement. Okay? Cool. Awesome.